Welcome back everyone to Data Science for Everyone. Today we're going to be predicting diabetes with PySpark. Let's get started. So this is going to be the first of probably a three-part series. This first part is we're going to be basically doing the Exploratory Data Analysis, so our EDA, for the Diabetes Dataset. So let's go on and get started. And again, we're going to be doing this with PySpark. Okay, so from PySpark.sql, we want to import our Spark session, and let me zoom in a little bit for you guys. So yeah, that'll be fine. So let's go on and create up our data. So PySpark, or we'll actually just create up a Spark session. So Spark is equal to Spark session dot builder dot app name here, and we'll call this diabetes, and then we want to either get or create, and then let's go on and create up the data. So spark.read.csv, this is going to be diabetes.csv, header is true, infer schema is true, df.show 2. And we see here that data looks nice. We have pregnancy, glucose, number of pregnancies, sorry, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, age, and outcome. So outcome here is whether they have diabetes or not. We'll change this a little bit so that we can kind of play around with it. Same thing with the age. And we'll probably, I think everything else looks pretty good. So let's go on and say, let's look and see exactly what everything looks like. So let's print the schema. So again, these all look okay. Everything's double. Everything's in an integer. There's no missing data in there. So let's go on and maybe look at our description. So df dot describe dot to pandas, so that actually looks clean here. And we see whoa, number of pregnancies 17 here. So again, maybe that seems an awful lot. So glucose levels, blood pressure, everything seems to be doing quite well, as well as our outcome. Now, one thing that we want to do is we want to double check on outcome, because this is what we're actually interested in. So let's go on and do a bit of a count. So df.group by, we want outcome dot count dot show. Has diabetes is 268, does not is 500. So this is definitely an unbalanced grouping that we have here, and that's okay. Let's go on and also take a look at some visualization. So let's do import matplotlib, pyplot is plt, import cborn as SNS. And let's do a basic histogram first. So fig is equal to plt dot figure. Let's do a fig size here of let's make it big, 25 by 15. So we want our subtitle here, fig dot what? Supplementary title is distribution of features. Then we'll want our font size here to be 50, and then we also want some vertical alignment as well. So let's do vertical alignment is going to be our center. You know what, maybe I should zoom out a little bit. for you guys. Hopefully you guys can read that. And then we'll do something like for column number in zip, and here df.to pandas data frame dot describe here dot columns. We want what, comma, range from 1 to 11. And then what will we do here? So axis is equal to our figure dot add subplot. We'll do 3 by 4 by the number that we have there. Axis dot hist df dot to pandas of the column. Then we'll do what? plt.grid. Let's turn the grid off, so false. We want to also do plt.xticks here. Let's do a rotation of 45 degrees with a font size here of 20. Then we also want plt.yticks, font size here of 15. plt.title. We want the column of the to be uppercase, the font size here to be 20, and then let's go on and make this a tight fit. We want to set y to be at 0.95. And then we'll also do fig dot subplot adjust. So we want to give it a little bit of space here, so 0.85, and our horizontal space here, let's do something like 0.4. We'll do plt.show. So this will take a second. Whoops, and what? It didn't like my subscriptable. That's because this needs to be closed. And subplots adjust. All right, so we can definitely see here pregnancies are skewed. Glucose levels are relatively normally distributed. Some are very low. We have some fattening, a fat tail here. Blood pressure, again, I'm looking at these numbers here. Maybe some of these people were dead. Then we also have in here skin thickness is definitely skewed to normal. Same thing with insulin. BMI is relatively normal-ish. Diabetes pedigree function is definitely skewed. Same with age. And our outcome, again, we know it's binomial. So again, some of this I would maybe be skeptical on some of this because you have some spikes here. Okay, same with the blood pressure and this. So maybe there's some messy data in here, but we're not going to worry about too much of the messy data right now. So let's not worry about it. Now let's also go on, and the next thing is we need to also check for some NAs. Okay, so let's do from PySpark.sql.functions. Let's import is nan, when, count, and we'll need column later on, so let's also grab column. So df.select here, we want count when is nan of c, comma c, dot alias of c for c in dataframe.columns. Notice again that was just a list comprehension, okay, for the selection dot to pandas dot head. Okay, so notice right across the board we have no missing data. This is just a nice little function I decided I should probably show you guys just to check for missing values. Again, we can also kind of check that from some of these that we don't have any nullables. Well, not in that, but whenever we're looking at our descriptive statistics. Now, the next thing that we're going to want to do in here is to create up some user-defined functions. Okay, so this is going to be what? Sub 3 user-defined functions. Okay. There we go. Sorry, my computer was off kilter there. So from PySpark .sql.functions, we're going to import UDF. Then from PySpark.sql.types, we're going to import string type. And some of this, you could call this useless. Some of you can call it just fun. But again, right now we just want to practice using some PySpark functions. So y UDF here is going to be UDF lambda y such that no. If y is equal to 0, else yes. So what we're doing here is we're creating up and we want string type. We're going to create up a function here where we can create up a yes, no for our outcome. Okay, so whether yes they have diabetes or no. Again, it being a numerical already means it was in a good form, but we're also going to, again, remember this is about practicing. Okay, so we want to be able to convert things to and from different types of order. So we're going to write this df.with column here, and we're going to call this has diabetes, okay, comma y UDF on outcome, okay, and then we want to drop outcome. So let's take a look, and now we have this has diabetes, yes, no, yes. Okay, so that's nice way to do that. And another thing that we want to do is, so age, if we go back up and we saw the age, we definitely had it skewed. Okay, so one thing that we can do, and what's also useful, so if we're talking about when people may have diabetes or whatnot, is to actually create up a some bands. Okay, so we can do it for their age groupings. Okay, so UDF multi here will be for age. So if age is less than or equal to 25, let's say return under 25 or 25, or yeah, let's just say under 25 for now. LF here, age is greater than equal to 25, and age is less than or equal to 35, and this needs to be less than. We'll do something like return between 25 and 35. LF age is greater than 35 and age is less than 50. Return something like between 36 and 50. Else, no, let's do LF age is greater than or equal to 50. We want return over 50, else let's return NA. Okay, just to cover our bases. So we'll do age UDF is UDF of our UDF multi. Then we can do df is equal to df.width column. Age UDF age UDF of age, and we can df.show 2. Okay, so now we have this UDF age here, and we have over 50, between 25 and 35 for some example there. Now let's go on and make a little bit of tabulation on everything from each of those groupings. So let's do, for example, some user counts, the average glucose for each of these age groups here. Okay, we'll also do the min and the max and the percentage. Okay, so then we can check our groupings that way. So we need a couple things from here. So from PySpark.SQL, we're going to import functions as f. From PySpark .SQL.functions, we want to import rank, sum, column, and descend. I think we've already done column, so let's not import it again. And then we'll do from PySpark.SQL, we're going to import window. So because we're technically doing a window tabulation. So the window itself is going to be window.rows between. Okay, so we want window.unbounded preceding, and then window here dot unbounded following. Okay, so then let's go on and create up some table. Maybe do, yeah, age group tab for table. So df.select here, and we want age UDF, and we want their glucose. Okay. All right, and let's do group by here. We want age UDF. We want to use the ag function here. So f.count, we want glucose.alias of user count, f.mean of glucose, dot alias of glucose average, and I'm going to, yeah, that's fine. Don't get lazy. So f dot min of our glucose dot alias of glucose min. Then we'll do f dot max glucose dot alias glucose max. Let's let's give it some space here. So with column, here we want to create a total. Oh, whoops. Almost made a mistake here. Okay, because that ag is 1. All right, so then this is going to be another one. So this is creating some descriptive statistics kind of all in one using this ag function. So it's going to be creating each of these columns. Now when we want other columns, okay, we need to do with column on here, and so we'll say total sum of our column called user count. So because we're wanting to access these new variables that we've had. Dot over window, and then with column we want to create percent, and this is going to be using column user count multiplied by 100 divided by our column called total. And then we want to drop this column called total. And then we're going to sort these descending order by percent. Now, if you're not used to this, this is absolutely magical. Okay, we are able to actively, again, because we're doing this on a server, we're able to grab the data, we're going to be able to do some calculations, and then we're going to be getting back a very nice table. Oh, and we have some misspellings in there. And so let's do something like age group tab dot show. And you know what? Let's do 2 pandas. It may look bad this way though. No, it looks okay. So now we have our UDF age. So we have our grouping, we have our user counts, we have our average glucose. For each of these, we have our min, our max, glucose, and then our percents in here. Now, this is, again, very, very useful to us to be able to look at each of these groupings. A couple things that we could do all kinds of basic plots in here. We could also look at, for example, how much each of these groups, okay? So, for example, here we have, like, this group is 23% of the total, so all of these are going to add up to our 100%. So we could do a couple different things. So let's do what? I'm going to go on and just copy this and do something like dot plot kind is equal to bar. You know what? Maybe we'll actually do this. SNS dot bar plot, and then our data is going to be this, and then we'll have something like x is equal to what? Age UDF, and then y is equal to our percent. And so now we can actually get this nice nice little visualization here of each of these saying which group is the largest or which group is the smallest. Now, some people and some of you may be very tempted to do the hideous faux pas of creating up a pie chart. We can do that, but this is definitely the better way because humans are not very good at understanding groupings in pie charts, even though this one would be quite obvious. But this is one way to go about doing it. Now, one more thing that we would do here is maybe let's go on and do some correlation. Okay, so let's do some correlation. Okay, and just some basic correlation. So first off is we need to make sure and grab only the numeric types. Okay, so if we actually look at our data set here, if we look at our raw data set, let's do info, well, dot print schema. Okay, now we currently have a little bit of a problem, right? Now we have two of these variables that are actually strings. All right, so let's go on and actually write up something just to grab the numeric features. Okay, now again, yeah, you can see them and you can pick them out, but let's say that you have a gigantic data set, okay? Well, then you may not be able to go through all of them manually. It's much easier just to write up a function for it. So T for T in dataframe.dtypes, if T1, okay, is not equal to string. Okay, so this will get all of our numeric features. So let's say numeric features data frame is going to be df.select here, numeric features. And then let's go on and say numeric features data frame dot to pandas dot head. So now we see here, now we have all of our numeric data. Using this nice little quick code, we can cut through it. So the next thing that we want to do is to actually create up a nice statistical layout for us. So let's do something like column names, and this is just going to be for us to create a nice, pretty analysis, okay, or table, let's say. Numeric features, df.columns. And then we'll do features is equal to numeric df.rdd.map lambda row such that row 0 all the way through gives us our features. And then from PySpark.mllib.stat import statistics. Okay, and let's import pandas as PD as well. And then we'll do a correlation matrix. Here is our statistics dot correlation. We want our features. And then we want the method here. Let's do Pearson. A Pearson correlation. Correlation data frame here is equal to pd.data frame. We want the correlation matrix. Then let's go on and say correlation data frame dot index here is going to be our column names, and then our correlation data frame dot columns is equal to our column names as well. And then we can round our whole data frame to 2 decimal places so it looks nice and clean, and we can run that as well. So now we have a nice correlation matrix here, and we can see that all of our data is, again, we have high correlation, low correlation. Another thing that we could do with this is also create up a nice heat map. So sns.heatmap, and then we can do correlation data frame, I believe. And we can see a nice correlation heat map of everything, and we can see our low variables and our high variables with each of these. So again, moderately highs are low with our pregnancies. Lows here are skin thickness. Again, we have some red in here with skin thickness and insulin. We also have some higher correlation with our BMI and skin thickness. etc. So we can also look at our glucose levels. It lights up a little bit with our insulin and with our age a little bit. So guys, I hope you liked this. If you did, please comment, subscribe, and hit that like button, and I will definitely see you guys next time. Bye-bye.